You're listening to a Pop House Network podcast for developers by developers. Welcome to Java Pop House episode 101. Hey everyone, it's been a while. We kind of took a little bit of a summer break, trying to enjoy the long days and the summer breeze. But like everything, weather is turning a little, and projects are coming up and popping up. So we decided that, gosh, we need to really put something out there. So it's this is going to be a very, very fun one. For those who are tuning for the first time or rediscovering us, my name is Freddie Guime. I am one of the co-hosts here at the Java Pop House. I'm a distinguished principal engineer at Expedia, author, speaker, Seattle Java Users Group co-organizer, and I'm here with my usual suspect, Bob.
All right. Hey, everybody. I'm Bob Paulin. I'm an independent consultant from Chicago working on JVM stuff, Apache Software Foundation member, PMC and committer. I am the CJUG board chair, speaker, and that's me. And I've also been taking time off, mostly because of Freddie makes it sound like, we just took the summer off to be chill, but we've all been kind of working our butt off. So that's probably the real reason.
Okay, fine. I am looking forward to Christmas.
We got to get back to our viewers, and we got to get back to this. And honestly, like this is fun for us. So I hope you guys enjoy listening. We enjoy making these. So.
Yeah. So before we dive in, I wanted to thank our sponsors. Today's show is sponsored by Datadog, a monitoring and analytics platform that integrates with over 450 technologies, including AWS services, Docker, and Kubernetes. Datadog's platforms brings together metrics, traces, and logs in one place, so you can get full visibility in your environment and improve your application performance. With machine learning-based alerts, customizable dashboards, and distributed tracing, Datadog makes it easy to unify disparate data sources so you can troubleshoot faster. Start your free Datadog trial today. Listeners of this podcast will receive a free t-shirt once you install the agent and create one dashboard. Visit javapophouse.com/Datadog to get started. And again, that URL is javapophouse.com/Datadog. We thank them for sponsoring the podcast and keeping our drinks full while we record these exciting new episodes. So this episode, it's more cloud stuff.
Yeah, a little bit more cloud. I mean, we promised more cloud stuff. We promised we'd be setting up VPCs and all that. And we kind of like, okay, let's back up here and talk about other functional Java-based stuff that are happening in the cloud. So here we are, and we're talking about
Apache Kafka.
Yes.
So for those who don't know, and again, let's first describe what Kafka is. It's essentially almost like a message broker. Essentially, with a lot of it is capacity for queuing. It's an Apache project. It's run by Confluent. And
it's not run. It's an Apache project, Freddie. You can't say it's run by Confluent or I'm
Spring. Right.
No. It's an Apache governed project, so you can't say it's run. Confluent is a major contributor to Kafka, though. I mean, it is fair to call that out. It is a broker system, and I think one of the more interesting things about it is a distributed broker system that is very well used. I mean, I was just on the Kafka site, and I remember like a long time ago. I was talking to Cedric Hurst about Kafka when it was fairly new, because he's always into the bleeding edge stuff. Right. And now I'm looking at the website, and it's like 80% of the S&P 500 is using Kafka. So it is everywhere now. Or Fortune 100. I'm sorry. So the really big companies are all using Kafka, and not surprisingly, because the entire concept of having cloud architecture, having eventually consistent pub sub models within microservices and within architectures is extremely popular right now.
Right, and that is as to dive in. One of the reasons is it's when you want to think architecture, right? You start getting into this, a little bit of like, okay, so it sends message from point A to point B. I can do that other ways, right? I can do a REST call to another service, and they have an endpoint, and I tell them what I want them to tell them, right? So a little bit of like the background is around messaging and this either queues or topics or a combination of both. Like, why do you use that instead of your traditional I'm just going to call you because I have a message for you?
Yeah, I mean, let's start with the really basic things. So, I mean, when we all got started, even before microservices was a big thing, and REST was the biggest thing. It's like, yeah, we're going to connect everything over HTTP. Everything's going to call each other. And one of the things we found when we did that is that stuff is not always available. Stuff breaks from time to time. Stuff gets slow from time to time. So REST is really a great architecture, and connecting things with HTTP in general is a great architecture when you're trying to make real-time information available. Because if I've got a person in a web browser that's just sitting there and waiting for a response to come back to tell them whether they got a ticket to their favorite event, whether they got a flight, whether, in something that they're waiting on real time, REST is one way to make sure that I'm going to make a connection. I'm going to wait for the data to come back, and I'm going to deliver that data within a certain timeout or a read timeout if things are slowing down to that user. But I think what we found is when we started breaking things apart, not everything requires that. Like, there's certain things that's like, hey, something happened. You need to tell me about it. If I know when exactly it happened, like, yeah, that's fine. Give me a timestamp. But if I don't find out till later,
immediately,
not a big deal. So things like messaging, where it was asynchronous messaging, started to become very popular. Like, so I mean, projects in the Apache ecosystem, like ActiveMQ, started propping up where you could have something published into ActiveMQ from a producer, and then something that would then read it later. And if that thing was down, or if there was something that was wrong with the producer at the time when you're reading from it, as long as ActiveMQ was up, I could read that message off and I could process that. And if I'm down, I'm not reading the message, so the message is still there. And I'm just able to eventually find out what happened. So the evolution from, hey, I just need to know everything real time, to, hey, just let me know when this stuff happens, is where a lot of this came from. And what I'm describing right now is sort of like a queue architecture where, hey, something went in and now I'm going to read it in some sort of order on the other end when it comes out. But we've actually gotten to a point where we've really diversified the different pub sub models where, hey, I'm creating topics, and I'm able to subscribe to topics. So I may have more than one subscriber that are reading at different times, that are tracking where they are at draining that specific topic through a subscription. So we're in a world right now where there are a ton of different models for doing asynchronous processing, in-stream processing. So Kafka is probably one of the most popular hub subs of subscription, not a queue, but a subscription model, processors of data, because you have it's distributed, and so it can scale probably a lot better than what a dedicated queue, where it's just like, hey, I got one server or one instance, maybe with some failover, where I'm sending things and reading things from it. It's like, this is actually a system where it's like, I can throw a bunch of stuff at it and be reading a bunch of stuff at it at high volume, and it works.
Skills.
There's certain things we trade off to get that, but it's a system that works in that model. So what may make sense, Freddie, is maybe just taking a moment, like I kind of breezed through this really quick, but just talking about the different data structures that exist, queue versus subscription, topic, pub sub, versus what we're saying is kind of the real-time thing, which is REST or HTTP.
Right. It's like RCP, really.
RCP. Sure. Yeah. Let's call it that just to be more generic.
Yeah. And like, for those who've never been exposed to this, the way that this works is the concept of topics, right? Is that it's almost like they call it like message buses, right? Like where essentially you can think about it as a thin line, and there's things that you put in, like you publish in the topic, you put in a message in the topic, and then whoever is subscribed to that topic will get that. Well, there's multiple ways that happens, right?
But you've hit it on a very, very key thing. Just to like pause here for a second. Producers in a topic subscription model, producers are talking to the topic. So when I am sending data, I am sending things to the topic. I'm publishing is what they call it, to the topic. Subscribing is the read operation. Right. So subscribing is when I'm pulling things off and doing something with it. Right. And I could have one or many subscriptions to that same topic.
Yeah.
And that's a really key point.
Yeah. And it could be like interesting too, because like traditionally what happens is that, let's say that I have 4 or 5 subscribers on this side, and I have one producer. If I, like what one of the setups is like, I put in a message on the producer, and that message will get to the 5 subscribers.
Yep.
Like essentially, and if this sounds a little bit familiar, these are actually enterprise integration patterns. Like it's a big book called Enterprise Integration Patterns. It's like, if you've ever seen it, it's a black book cover. It's not the GAN 4. It's
no. That's the other design patterns. Yeah. I know what you're talking about. So Enterprise Integration Patterns is a book. I'm a big Apache Camel fan. So, I mean, you can see more of them in Camel than anywhere else, but Kafka represents one of those integration patterns, which is a topic subscriber pattern. Now, one of the things you mentioned that I think is really key when you're evaluating, well, do I need topics and subscriptions or do I need a queue, is when I push something into a topic, I can have 5 subscribers get the same message. Now, if I'm using a queue, once I read that message off, typically I'm going to commit back to that queue and say I read it. And then anybody else that is listening to things at that queue is not going to get that message. Right. So a queue is not really for spreading things out. A queue is almost there to do a thing called idempotence, right? So I'm going to make sure that exactly one consumer gets this message because they're going to read it, they're going to commit it, and then I'm going to say it's gone within the queue. So ActiveMQ is more of a queue type data structure where once I read it, I'm going to say, hey, I sent it off, we're done here. Whereas a topic is going to have a bunch of messages in it. I may have many subscribers, and the subscribers, if I don't say anything, I'm going to pick it up from the beginning and I'm going to read everything until I'm done.
Yep.
I could also say, I don't want to read everything from the beginning. I could also say, I'm going to pick it up in the middle. I'm going to pick it up after a certain offset, which is a key thing in Kafka world of where I want to start within that topic. So if you've got systems where you have multiple systems that need to receive the same message, a topic subscription model is a good thing for you. But if you expect, hey, I want this read off exactly once, and then it disappears and nobody's going to get a duplicate message, you may want to look into a queue, an ActiveMQ type technology.
Yeah, no, and to make it more concrete, right? Like the 2 examples I have, right? Like for example, like one example is, and I'm gonna bring it home because it's something that like we work around. There is a publisher subscriber that we use where, for example, we notice a price that is out of trend, right? Like there's something that, let's say there's a flight that, like American Airlines decided to make very, very cheap. So what happens is we sort of have like this topic where we put it in and say like, hey, just so you know, we just spotted this very cheap flight, right? And we have different, so there's a producer that was, essentially reading the data, figure it out, put a message saying, price alert, there's a cheap flight, right? And there's consumers on the other end. And the consumers could be, one of them could be for the website, so if you're visiting the website, suddenly you get a pop-up saying that, hey, we noticed that you're looking for American airline flights and this is cheaper. Another one is a consumer for email. So, they can go to our email campaign. A third consumer would be for our packages team, because now they're thinking like, oh, with this cheap of a flight, we can package it with a nice hotel and create something cool to like advertise. So you can see it's almost like, it's the count of events, right? And you can think of them as signals. But one of the things is like, if there's something interesting happening that you don't quite know exactly how people are going to use it in the future, but that that is important information, then that sort of like starts gravitating to this kind of like messaging topic where you have a topic and you put it in there, and maybe there will be consumers interested in it, maybe there'll be nobody. But the way that this also feels is that if we were going to do this on the days before we have Kafka or ActiveMQ, then what it'll have to be is that, oh, I found a cheap price. My producer, whatever it is doing, needs to make a REST call to another service, passing the payload. Hey, I saw a price, right? And if suddenly you see yourself doing the same copy and paste that code and making another REST call to another service that is, expecting it in a maybe a little bit different format, but expected some kind of response, then that is a hint that you might be looking for like topics, right?
Yep. So and it is often possible to take something that you want to work as a queue and make it work sort of in that topic subscriber model. If you only have a single subscription ever, and you're able to programmatically kind of enforce that in your architecture, you can make a topic subscription kind of work like a queue. Now, the sort of important thing is once you start talking about technology platforms like Kafka, like once you get into the distributed world, making sure the order is perfect becomes very difficult, right? So if I have one ActiveMQ broker and everything is publishing to that, getting things in the right order turns out to be very simple. That has a scalability problem, but I can make things happen in order. When you start talking about Kafka and you're talking about topics and subscriptions, we kind of put order out the window a little bit. Like we'll do our best, but we're not going to guarantee it anymore because there's many different brokers that could receive your message, and there's many different subscriptions that could be reading things off of the off of that topic.
And there's at most ones or only ones, at least ones, kind of like deliberate schemes. Like the other thing that is interesting is on the other side of the equation. Well, first of all, do not implement your own sequencing messaging platform, please.
Hopefully you already figured that out.
Yeah, right. Like SSL is the very first one. That's still number one. Never implement your own SSL.
Yeah.
A close second will be don't create your own messaging framework, right? Like just pick one.
You could say that, but like you look at the proliferation of messaging frameworks out there right now. I mean, and I'm just talking about the ASF ecosystem. There are a lot of messaging things out there, but the idea is they meet different constraints, right? So ActiveMQ right. meeting a queuing constraint and Kafka meeting a pub sub topic subscription model. Like they're meant really for different use cases. So the important part is understanding what your use case is, understanding, what you can put in your environment and support. Those become important topics for trying to decide like which messaging technology should I be using? Because the one thing that I hope you've figured out by now is REST is not right for everything.
Yes. No, and that is going to the second part, like, on the queuing side, right? Like the one where you send a message and maybe you have 5 consumers, but only one of them will get the message. A second consumer will get a different message. The third consumer will get a different message. The reason why you have a structure or like the use case that you get into that is when you are distributing work. right? Let's say that you have, a queue with 300 orders, right, that need to be processed and shipped, right? And they, essentially they get published, and you have consumers, which is essentially machines that are doing the work, like on a different cluster. And then, they get, you start publishing these messages. And as soon as one machine is free to do work, it'll pick that message, process it, do all this stuff, create the shipping labels, and send it out there, right? So the advantage that you have with this kind of like asynchronous structure is that, for example, let's say that the work it's a holiday or Black Friday, right? And you need to up the number of orders that you're going to be receiving. Yep. You can essentially take, instead of saying 5 consumers of this particular topic or queue, I want to make 20 of them, right? And for the 3 days that you're running your promotions, you got the extra compute capacity. And you didn't have to, the only thing you have to change is like 2 numbers about how to scale. And it just magically happens. Like you don't have to deal with like, no, I need to subscribe to, or I need to register a new processor or anything like that. It's just spin up, gets the topic, starts getting messages, starts processing them out.
Well, and you have to consider the failure situation. So, I mean, queues and PubSub are very popular on Black Friday, because if I have real time for things and I am over capacity, what happens, right? So in let's say it's a Java EE application, I'm going to run out of threads. What happens when I run out of threads? Well, I got to wait, and those waits are going to time out. And those are orders that I'm not going to receive. If I have a messaging framework, I have a little bit of elasticity, right? So I'm going to put that in a queue, and the systems that are reading off of that queue, or that reading from the subscription, the topic as a subscription, they're pulling as fast as they can, but no faster. There's no force. It's a pull, not a push.
Right,
so.
Right. So if
I find that queue is getting really big, as Freddie described, I can add additional processes, and I'm not failing orders at that time in an e-commerce system. So I want to make sure the queue doesn't get maxed out, or the storage that I have for between the readers and the writers doesn't get maxed out, but I have a little bit of wiggle room there. So when I see that getting big, I can add processors on the consumer end, and eventually I'm going to catch up. And I'm not going to miss anything.
Yep. Yeah. Right? And that is like the like you're saying, Bob, like that elasticity is key, right? Like, because
it's huge.
Like our systems used to be monolithic. It was just one thing that did everything. Microservices allow us to split it up. But the thing that this introduces, and this is the reason the enterprise integration patterns and messaging frameworks such like Kafka and JMS allow us to do, is that now these parts can grow or shrink depending on their needs. And we don't have to worry about, if you set it up right, it works so beautifully, because you don't have to do the like, oh gosh, I need to rediscover my cluster or anything like that. I think that almost get us to like, closer to like what Kafka brings, right? Like and a little bit of like comparison with like you said, Kafka is not the first or the last one. There's a bunch of other ones that are out there, like JMS, right? Mm-hmm. And I think, like I said, we have that in episode 20 something when we talk about JMS.
You have to go way back, but I mean the standards, like there's JMS 1 and maybe 1.1 and then 2. Like, so I mean there's only a few JMS standards that you got to know. But we're talking about Kafka today. So JMS does not work with Kafka. JMS is really more of, you're talking about your ActiveMQ type systems, which work a little differently.
Right. And then just so we can start getting into like a little bit of the difference. We're not going to go completely deep on it, but JMS, it is a JSR standard, is Java messaging system or
service system. Yeah, I'd have to Google it. I'll Google it. You just keep talking.
So what they did is like they define it essentially service. All right. Like, so they define it like what it's supposed to support, what kind of like message structure you should have. all these things, right? So technically you can have different implementations of JMS. That's the advantage of the JSRs, to interoperate or being able to swap it, right? Like the most famous ones are ActiveMQ, which is, I think, another Apache project.
Yep. Got RabbitMQ. Like there's a lot of
RabbitMQ, and there's like, there was a couple that are like C++ based that are like the financial industry. I cannot remember. But yeah, but like one of those things is like there is a concept of a broker, like one big piece of hunk of metal where that is the one who's trying to drive traffic around everything, right? Now Kafka, on the other hand, is not necessarily like it's not a standard. So if you have something that is playing on JMS from one side, you will need to. I mean, there are ways to bridge them, but it's not like you can replace.
It's not direct though.
Yeah. So like one of the interesting parts about and the reason why like Bob was saying, Kafka is making such a big footprint on the our industry is because the concept of a distributed broker that can scale horizontally, right? Like ActiveMQ was designed with one broker in mind, and it's not like they cannot do multiple brokers. I think like everything else, we're moving that way, but there was an inherent advantage of Kafka just being distributed first, right? Like so it uses I think you were saying like it uses Zookeeper, I think, for discovery of the cluster.
Right. So you can have many brokers, right? And you can have a Zookeeper instance. So your client is going to use Zookeeper to say, okay, I'm going to connect to this one versus another. So again, in the terms of distributed systems, Zookeeper is a foundational technology for things that are trying to load balance or things that are trying to have auto discovery, where you have different keys and pointing around. So Kafka has all of that baked in.
Yeah, and the fun part is that because of it, right? Like maybe what I should do is like let me show a little bit of an example of back to basics example of how this works. Let's see, I'm gonna share the right screen. Yeah. I hope you can see my screen now. Let me see if
I can see it okay.
Let me go into print center mode. It's somewhere here. You
don't know the key shortcut for this, Freddie?
I don't do that many presentations of code.
Oh, he's slacking.
Oh, now you're making me like nervous now.
I'm the same way.
You know what? Let's
the experience you've got right now, Freddie, it's fine. Like I can read it.
No, I remember that we got a comment once about
all right, you do your thing.
Yeah, I will find it. Just give me 2 minutes and then and I know this is so and I'm gonna kick myself in the bum because it's like
you're an IntelliJ, so
yeah, I know you're like I cannot ask for your help.
I can't help. I'm an Eclipse guy, so
yeah, it should have been here. You know what? In the meantime, as we go through, let me go with what I searched for this. So the way that Kafka works is like we said, there's a producer and consumer, and that is sort of like what we created, right? Like we actually, I'm just gonna go over the code real quick. What we do is, and actually, they removed that. You should be able. You used to be able to like.
We need Trisha G, don't we?
Yeah,
tell you all of your shortcuts for IntelliJ, as if she doesn't have better things to do. There you go.
I found it. They move it inside a little like pull out. That's why I didn't.
There you go. Nope, that looks perfect.
But so the way it works is like we have this is the main of my program, right? Like we have a producer class, a consumer class, And what I'm doing is I'm creating, it's almost like that magic trick. Like this is when I'm going to create a new thread with a producer. I'm going to create a new thread for the consumer.
But he loves threads.
And then
Still
just start it. Right?
No thread executor, just threads.
Yeah, this is as bare metal as you can get.
Yeah,
right?
no, it's
so let's go to the
1990s called.
I still remember. We remember. Oh, that would be great for a t-shirt. You just have like new thread. It's like we remember. It's like old knowledge. It's gonna be out now that Loom is coming. But
yeah, virtual thread, not thread anymore.
So the producer, very simple, right? We create a properties class, which is essentially a glorified key value map. And we put in certain things like, the key serializer, which is like, what is my serializer for the key, the value serializer, what is my serializer for value? And that is one thing is like the way that the messages are structured in Kafka is that they always come as a key value pair. And the reason is because then they figure out that just having that level of abstraction from the get-go just makes it super easy for you to distinguish what kind of message that you're encoding or are you interested in the messages that have this particular key and stuff like that, right? So so these are essentially the serializers. You put in the key serializer, you put in the class that is in charge of serializing it. And then, you can have your own implementations if you really want something, more elaborate than just your plain strings, right? There's a string serializer where you can just send strings out.
It's a good one to get started with, because if you don't know how the serialization works, it's really more of an optimization to change what your serializer is, right? So you get a string, you can turn that into an object. You can use, Jackson or something like that. If it's JSON, you have options. So this is a good starter example.
Right. And then you just put in the client ID. Bootstrap servers is where your server is located.
Yep. And there's sometimes more than one of these. Again, typically with Kafka, you may have a comma separated list of these. Mm-hmm. If you're truly distributed or using a managed service.
Right. And then you just create the Kafka producer, with the that we put in as stuff. The Kafka producer itself has a method called send. You create a producer record, you let it know what topic you want to essentially publish on. Mm-hmm. And then you pass in your key, you pass in your value. These are essentially like templatized here, right? So you just pass in key value and off to the races. That's all on the producer.
Yep.
Right. Now on the other side, we have the consumer, right? Consumer goes through almost the same thing. There's a properties file, properties object where you put in where is your Bootstrap servers located, your deserializer for your key and value, couple other like things like, for example, auto commit interval milliseconds. Like you just after reading this much, we're just going to commit that we read all this.
Yep. That keeps your offset up to date, so you don't replay additional or a second time.
Correct. Right. And then when we get it, the producer, what we do is like we do essentially this hot loop. Not quite hot because we do the poll with 1,000 seconds, and what that means is that it's going to stay here for a second if there's nothing, and then it's going to break out and run. But if it's something is received, then it will immediately break out and then just execute on that, right? So even though it's a while through, these are usually called like hot loops. It's not that hot because it is actually, it's IO bound.
You'll pause on the poll because if there's not data, even though it's while true, the thread is gonna wait.
Yeah. And that is very important for every while true that you have. If it's gonna be long lived, right? Unless you're doing something very, very specific, they're usually nasty. Like they're bad for your processors. bad for the code itself, unless you have a very specific reason. And in this particular case is fine because we are actually, like you said, we're actually
Freddie's saying don't copy our code for your production system. I mean, there are other frameworks around it for reading. And we'll chat a little bit about that later. Right.
So let's build out. And as you can see,
boom.
Right, like
there it goes.
Send message. And
okay, you got your consumer up.
Yeah.
Or that's just reading it? Okay, there you go.
Consumer is going in. The offset. Oh, the consumer has been running for a while because you can see the offset is not started from zero.
Well, those are persistent, right? So I mean, if your system, your reader goes down and you've persisted your offset to the Kafka broker, when you pick it back up again, you're going to pick up where you left off, and that's a really important feature of Kafka.
Yeah.
Because if that's not there, you start from the beginning. In Kafka, you can expire messages, so they do eventually go away, or they're out of storage. But like otherwise, you're starting from the beginning of time.
Yeah, and that is like, this is as simple as it gets in terms of like how to do this. The things that were a little hand wavy is like like I do have like a Kafka broker running locally, and and I know going through that, because usually what happens is companies already have either in-house provision these things, and once you have a Kafka broker running somewhere, you just need to know where it is to connect to it, or you're on some cloud providers, right, Bob?
Yeah, I mean, so the companies that I've worked with Kafka, they're not running Kafka locally. Like, so if you're on AWS, for example, there's MSK Connect on AWS, which will spin up your brokers. And, again, you can start with something minimalistic where you'll have 3 brokers. So you'll have a common separated list of 3 Bootstrap servers that are running for you in AWS. And they actually even provide a little bit of a scaffolding around your clients, where they'll provide MSK Connect clients. So there's some open source frameworks, and Freddie already mentioned Confluent. They are very active in the Kafka space. They have a framework called Kafka Connect, which allows you to kind of set up source and sync connectors, where if I'm coming from Kafka and putting it into a database or Hadoop or somewhere else, I can create a sync. Or if I'm taking things out of a database, I can create a source connector and say, okay, read this and publish this to Kafka. And a lot of the code that you're seeing that Freddie wrote, where you've got that hot while loop, is really what the framework is doing for you. You're telling it, hey, these are the Bootstrap servers. This is how I want to handle my offset. This is what topic I want to publish or read from. It all comes from the configuration files, but you're using the framework to essentially wrap how I'm polling or how I'm pushing or publishing, to Kafka. From there, but I'm using just plain old Java objects, and my return statement is really just, hey, publish this. So frameworks, in a sense, as useful it is to see kind of how things work under the covers with what Freddie shared. How a lot of folks are doing Kafka development these days are using the frameworks, and they're putting it in between Kafka and some other source, or they're reading from some other source and pushing the stuff into Kafka.
Right. And that is, it is kind of like the fun part, and one of the reasons this becomes pervasive is because, say that you're starting to publish this, like let's say this events, like, price alert events, right? Using like Kafka Connect, I can say, like, I want to write this price alert into a database. Right. Mm-hmm. And suddenly then I can have, I want to do aggregations in them. And then I can do, what is the average move of this for the past hour? Right. So then I can create another source that actually takes, maybe that's some like messaging on the database and produces a new thing. So it's kind of fun, because now you have this little discrete like events that are being, queued or published on these topics, and you kind of like draw a line with them, with some kind of transforms, right? And then Kafka Connect allows you to do that. And the fun part is that you can keep adding lines to it to transform it every other way that you need to, and it's not that big of a deal. Like before messaging, this was like, oh, you need me to process the price alert message in a different way. That's going to be a new microservice or a new service. And I need, to put it on another database because ours cannot handle the read, right?
Yeah, no, that's absolutely correct. So, I mean, a lot of the code that you would use to either write to a database, write to Hadoop, or take from any of those sources and push up into a Kafka queue is already written for you in these Connect frameworks, right? So you have to manage the data transformation, which is the custom way that you're transforming the data object from the source or from Kafka before you persist it. And that's all set up for you. Definitely check those out, because usually Kafka is something in between, right? Kafka is not an end within itself. It is a way to get your data from one place to another. And what you're doing with that data after that is important, whether it's an application, whether I'm looking to create storage out of it so I can query it later, whether I'm trying to send it out to other systems from a data store. Those are the different use cases. And as Freddie mentioned, there are managed options out there in the cloud. The one I'll mention AWS just because that's the one that I have familiarity with, is their MSK Connect has both broker support where they'll manage the brokers for you, as well as the connector support where, you'll build a jar, you'll push it to S3, and then they will run that connector for you. And that connector can connect to a broker and as either a source or a sink, depending on whether you're pushing data or into Kafka or saving it.
Yeah, you don't even need a service.
It'll run it. So I mean, it's like an ECS type service for the Connect plugins, and it is pretty straightforward to use. Like I've had some success with it, and you can scale them up and down. So I mean that is the beauty of using a system like Kafka, is it's mature enough and people have used it enough where there's a lot of cloud services built around it. So as much as we like to study Freddie's code, you don't have to do that necessarily if you're trying to get into Kafka and get the benefits of a subscription topic type architecture.
Right. No, yeah, like we went through the very basics, and maybe the basics is what you need. But if do check, like Bob said, like there is, like every architecture is different. But if it's something that is like, I need to go from database with topic to do a transform, there's probably a Kafka Connect already there for you.
Yep.
So yeah, just bring that in. Put the real business value, like Bob said, which is just the transform that you need to do, and let somebody else take care of the DevOps on it, right? So,
and I mean, if you're good with it being distributed, you're not going to be nitpicky about order. I mean, your order is going to be basically right, but it's not going to be as atomic as if you were publishing to an active MQQ.
That is one of the three most difficult computer science problems is like ordering on a distributed network. It's like efficient ordering. You can do the lazy ordering, which
I thought it was naming things off by one, or no, sorry, not off by one. The punchline, cache invalidation, and then you stop and wait for somebody to ask. Wait, you didn't say three.
We just
off by one errors.
We just follow all of them up.
Yeah. That's okay. It's Friday. I'm not good at jokes today.
Oh gosh, it's like we're already like in vacation,
It's the weekend is here. Yay! We earned it.
But yeah, so that is, I think that covers like the basics of it. More than anything, we did try to go over like what are kind of the code smells. Again, those if you see yourself connecting to try to publish to different or to call RCP to different services for this kind of the same thing, that is definitely a strong smell that a message queue, or it's or message topic messages or queues, it's something that can help you alleviate that. if you see yourself trying to elastically scale, and you have asynchronous number of workers versus the things that you're trying to process, that's another smell for it. But yeah, like these solutions are very, very proven. They are the way that we work now. I think that any system that is of a certain scale, once you start getting into more than 2 microservices, like you start thinking about this, because like
it comes up.
Yeah, it's gonna be in your future. So and if you're being always, if you're embedded into systems and you always hear about messaging but never got a chance to like look into it, go for it. Especially, if you're in a medium-sized house, even like the smaller houses will have some kind of like messaging framework already installed or running, right? Just take advantage of it. It's super easy to like tap in, and it's super easy to like start like producing and consuming. So and it solves a lot of like the enterprise integration problems.
Yeah, and I mean there are other connectors. So I mean, if you like the Confluent stuff, that's all open source. Camel has connectors to Kafka, so you don't have to feel like you have to write your own client or publishing to the broker yourself. There's a lot of frameworks and options out there for working with Kafka. Again, it is so popular that, again, there's Spring projects built around it. There's a lot of open source that you can evaluate. But yeah, don't do everything with REST if it doesn't make sense. Is I guess what is the end message to you?
Yeah, I was just gonna like plug in, like if you go to the Confluence page, Confluent page, we'll
Confluent.
Put it like,
Yes.
Yeah. Tim Bertling, who we know and love, created some super cool videos about like how they use Kafka and like what it is, right? So just to get more of that visual spread of the possibilities. So yeah, check them out and become the queen or king of asynchronous messaging. So
yeah, no, I mean it's one of those Apache open source projects that came out of LinkedIn. It's grown in popularity. I remember, I think I first went to a talk on it at an Apache Con in like 2014, if that's that old. Maybe not that old.
Back in the day.
It was a long time ago. But
we still didn't start.
Yeah. But it is a project, and if you're interested into it, again, it's an Apache project. You can contribute to it. You can check out a lot of open documentation on it. You can run it yourself if you want to, but there's also a lot of managed options because it is so popular. So definitely worth checking out, and figuring out how to add it to your architecture is an exercise that's definitely worth your time. Written in Scala. So it's funny because I feel like in our Pub House episode, we were bashing Scala a little bit as a bit of a niche language, but Kafka is written in Scala. So if you like Scala, that's one of those open source projects you can check out.
All right. And with that, I think that's all what we have for this episode. We're back, baby. We're back.
We're back.
Happy programming, everyone. All right. Take care.
Take care.
Woo-hoo.
Yay. We did it. We got